So maybe some of you have been thinking, why do I need to know factoring? Well, there's a lot of reasons. This section is one of them. In order to solve a quadratic equation, which means I need to find its x-intercepts before I graph it, I have to know how to factor. If I shoot a rocket up in the air, its trajectory is going to be a parabola because of gravity, and I want to know how long before it reaches the ground. Have to know how to solve a quadratic by factoring or quadratic formula. So, that's just a couple, but there are a lot of different reasons. If you're minimizing costs, maximizing profits, we have to find the vertex of the parabola. And if you want to know when 0 items would be sold, you can use that for pricing. So there's just a ton of reasons why you need to be able to factor, and it mostly goes with I need to be able to factor so I can solve a quadratic, a cubic, a quartic equation. So in this section, we're not only going to be factoring, but then we're actually going to be solving. So I want you to notice how the directions change, because on the final exam, I have solve equations and I have factor equations, and there's some students that just solve all of them. And then there's other students that just stop here on all of them. So if it says factor, that means turn it into a multiplication problem. This is where you would stop. If it says solve, you don't stop until you have 2 solutions if it's a second degree equation, 3 solutions if it's a third degree equation, 4 solutions if it's a fourth degree equation. So that's what solve means. Tell me the solutions. Yes, you do have to factor first, but then you keep on going. So make sure you understand the difference between those sets of directions. This is called factoring. Stop when you've turned it into a multiplication problem. This is called solving, when you've given the reader solutions that match the highest power. So if the highest power is 2, you should have 2 solutions in your solution set. So how do we solve an equation? This is how. It's called using the zero product rule along with factoring. So first we have to set the equation equal to 0, and it has to be in descending order. Then this is the reason we've done this entire chapter, so we know how to do this. We factor it as completely as we can. If it takes 3 steps of factoring, you factor it with 3 steps. So you factor it completely down. Then we apply the zero product rule. So let's say we have x minus 2 times x minus 3 equals 0. So on the left side, it's a multiplication problem. It's factored. So what the zero factor property says is if a times b equals 0, then either a is 0 or b is 0. And that's how I find the 2 solutions. So the first must be 0 or the second must be 0. And then I solve those, add 2, add 2, add 3, add 3, and I get my 2 solutions, 2 and 3. So that's where factoring comes in. So it gets us from here to here, and then this new zero product rule gets us moving on. So if you have 2 things multiplied together and they give you 0, one of those 2 things or both have to be 0. And then you solve, and let's go ahead and do that last step just so you don't wonder why I stopped there. So you get x equals 2 or x equals 3. So our solution set looks like 2 and 3. And I'm guaranteed 2 solutions if my original power, which you can see x times x is x squared, if my original power is x squared, I'm guaranteed 2 solutions. So you always have the same number of solutions as the highest power. So I applied the zero property rule right there. You should draw an arrow up to there and there. So that's called the zero product rule. If A times B equals 0, then either the first number is 0 or the second number is 0, and then you solve. Okay, so actually not really learning anything new here. You're just using everything you've ever done in factoring. So you already know how to factor, you already know how to solve an equation. So like I said, nothing new in this section. You're just putting some things together. So you're going to see a lot of AC method in this one. We haven't done AC for a couple sections, so this will be good practice. I do want you to notice that step 1 is you have to set it equal to 0. I can't tell you how many students start factoring and here they go, oh, there's an X common, and they take an X out. You cannot do any factoring until this is 0. And it's not 0 now, so don't start factoring. So to make it 0, you have to subtract 10. Minus 10, minus 10. Whatever you do to the right side, you do to the left side, and that produces this. So that's going to become 0, and then we have 6x squared plus 11x minus 10. Look for a GCF, which we've been trained. That's the first thing. There isn't one, so you can see this is going to be AC method because there's a number in front. So we're looking for factors of 60. Read the problem backwards. That's subtract to 11. So 1 and 60, nope, that doesn't subtract to 11. 2 and 30, nope. 3 and 20, that subtracts to 17. 4 and 15 it is. And so I didn't show that step. I just went straight to parentheses. So let's go ahead and show that step. So this says the signs will be different. And this says make the largest one plus. So 15 is going to be plus, 4 is going to be minus. And remember from AC method, then we go into grouping. So we take the 11x out and we replace it with these two. So 6x squared minus 4, use the same variable, x, plus 15x minus 10 equals 0. And don't drop that 0, otherwise you're going to turn it into a factoring problem and stop too soon. And then with AC method, after we replace that, remember we always do GCF. So GCF here is 2x. Divide each of these by 2x, and you get 3x minus 2. X's cancel. Bring down this sign, plus. GCF here is 5. So divide each of these by 5, and I get 3x minus 2. And this is when we celebrate, because this tells us we're doing the problem correctly. And then that comes out as the new GCF, 3x minus 2, and then what's left would be 2x plus 5. And that's where that came from. Then, once you get it in factored form, if A times B equals 0, either A is 0 or B is 0. So solve this, subtract 5, add 2, and we get 2x equals negative 5, 3x equals 2, divide by 2, divide by 3, and we get the two solutions of negative 5 halves and positive 2/3. Order doesn't matter in here. Some teachers are picky and they'll say, please do it smallest to largest, but doesn't matter. As long as this is squared and you have two solutions, you are good to go. And you always put 2 or more solutions in a solution set. It's not optional. Always. 2 or more solutions must be put in a solution set. Hence the word, right? Okay, you ready to practice on one of our own? This one is almost the same problem because look what AC is going to produce. 60! They love that. That's like the 4th time we've seen 60. So first off, step 1 is set it equal to 0. Done. Step 2 is multiply A times C. Why? Because there's no GCF. And when we have a trinomial where the leading term, excuse me, is not 1, we have to use AC. So this time we're looking for factors of 60, read the problem backwards, that subtract a 17. So with the same list above, 1 and 60, that doesn't subtract a 17. 2 and 30, that doesn't subtract a 17. 3 and 20, boom, subtract a 17. Now we have to deal with the signs. So this says the signs are different. And this says the larger number needs to be negative. So I go over here, larger negative, smaller positive. And then I take that middle term out and replace it with those two, listing the negative one first. So 12x squared minus 20, use that variable, x, plus 3x minus 5 equals 0. And then we learned after we do the AC, then it's turned into 4 terms, so we do grouping. GCF would be what? 4 and an x. So divide each of these by 4x, divide by 4x, and I get 3, 2 minus 1, x to the first, so 3x minus 5. Bring down this sign. GCF here is just 1 because nothing else is common, so when you divide by 1, you get 3x minus 5. And then we say, oh, we have another GCF, and we know we will if we've done it right because AC method requires 3 GCFs. So our third GCF is this common binomial, 3x minus 5, and then we have 4x plus 1 in the second parenthesis. Now this is where we use our new zero product rule. If A times B equals 0, so if we multiply two numbers together and it equals 0, one of those or both of those numbers must be 0. So we say, oh, okay, either 3x minus 5 equals 0 or 4x plus 1 equals 0. And that's where we get our two solutions from solving that. So add 5, 3x equals 5. So x is 5/3. There's my first solution. And then subtract 1, 4x equals negative 1. Divide by 4, so x equals negative 1/4. I like putting my answers in smallest to largest, so I'm going to do that. But order does not matter unless Alex tells you to put them in a certain order. Okay, so I check the power of 2, count the solutions 2, boom, I'm good. Okay. I think we might have time to do one more on the next page. I did put 1, 2, 3, 4, 5 of these on the test. So this is a huge section, and this is the last thing in your Alex pie. So you want to make sure you finish the pie so that you get to this stuff, because 5 questions out of 25, that's 20% of the test is from this one section. Okay. So next we have a problem that is not set equal to 0. So our first one was, this one is not. So we have to do the opposite to move everything over. So the 8x squared is already on the left, so it stays. 6x needs to move over, so when something crosses the equal, it changes signs. 1 needs to come over, so when it crosses the equal, it changes signs. So it's the same thing as doing this plus 6x plus 1 plus 6x plus 1. So change sides of the equal sign, you have to do the opposite. So there's our new problem. And we factored one like this earlier in I think 4.6. So we're looking for, there's no GCF, so we're looking for factors of 8 that add to 6. And we'll finish this on the next video.